In this video, we will see how the value of a polynomial at a certain number, let's say in this case a, p of a, how is that related to the remainder of the division of the polynomial by x minus a. And first, I want you guys to remember that when we had see, so when we had here, let's see if I can let you guys see better. So remember, if we have a number that we call here dividend divided by a divisor, in this case 3, the quotient as the number 2, that's the name of that number, and the remainder is the 1, right? So remember that from that, we learned that we could write this division into different ways. So one way is to think of, well, the dividend divided by the divisor equals the quotient plus the remainder divided by the divisor. So that's what we can see here. So we can say 7 divided by 3 equals 2, which is the quotient, plus 1 divided by 3. But it's not the only way. We can also write this as, and I'm about to show you here, thinking in a simpler way. I like it. It's if you multiply here by divisor, both sides of this equation, you get this equation down here, in which you now have only dividend equals, since you multiply by divisor to the right, you're going to have quotient times divisor plus remainder. So this denominator disappeared and that denominator disappeared, right? So this is same, thinking of that same example, it will be like 7 equals 2 plus 3 plus 1. All right, so kind of in a similar way we are going to do here, only we are going to do with polynomials. So, and I'm going to concentrate on these two numbers here. So if this is, let's say that is any polynomial in x, and if we are dividing by, let's say that the divisor right now will be of certain form, so let's say x minus a in this case. So clearly I'm going to get a quotient, and that is going to be a polynomial. More than likely it'll have a variable x somewhere. So it'll be the quotient x times x minus a plus the remainder. We can use r for remainder for right now, okay? So that means that we're gonna get something like this. So we divide, maybe I'm gonna take this off. I'm gonna use this here. So we're gonna get something like p of x divided by x minus a. I'm gonna get a quotient and I'm gonna get a remainder, right? So that means that if we concentrate in that form of writing the answer, I'm gonna have something like the polynomial, whatever is this polynomial here, equals the quotient times the divisor plus the remainder, okay? And I want you guys to notice what happens when we try to calculate, or that we try to replace the x by a. So we want to find p of a. So what value does the function takes when I replace the x by a? Well, like I said, all we are doing here is replacing the x by a. So when you do that, I'm gonna have to pull this up. Everything that is x up here will be replaced by a. So q of x will become q of a, where here I have x minus a, I will get a minus a plus the remainder. But of course, we all know that any number minus itself is 0. So this right here will be 0. And I also know that when I multiply any number times 0, I get 0. So this whole factor disappear because again, it's a number times 0 and that equals 0. So I'm left with the remainder. And this is what the remainder theorem says, that there are two ways to calculate the remainder when you're trying to divide a polynomial by x minus a. Yes, you can do the division, whether it is the common standard long division or synthetic division, it's okay. And you can find the remainder. Or you can just plug in here, instead of x, do a, plug in a into the polynomial, and you're gonna get the same answer. Okay, we'll see that in the example, but that is the main idea. So hopefully you follow that right there. Well, now I'm trying to get to the main screen here. So I need to get here. All right, so you'll see that happening here. What they did was synthetic division. So for synthetic division, don't forget that you just try to find the 0. So here we are dividing by x plus 5, and the value that makes this 0 is negative 5. So that's why you see here the value of a equals negative 5. And when they divide, they get remainder 4. So now let's see what we get when we replace into the polynomial. Well, we can do it here, but we could have done it also here. You know, when you do negative 5 to the third power plus 10 times negative 5 to the second plus 25 times negative 5 plus 24, you should get the same answer, 4. Okay, but they are just using this form of the polynomial. Remember, is the quotient times the divisor plus the remainder. And if you replace the x by negative 5, what I was pointing out before was that this is 0, and 0 times whatever, so I don't even care what this number is, all this multiplication or the answer will be 0, and 0 plus 4 is 4, so your final answer is going to be 4. All right, so that's the main idea of the remainder theorem. So that is to say that, here they made a slight mistake here because they didn't replace the x by a in Q. They should have, but that's going to become 0 anyways. And what you're left with is the remainder. Okay, so for a polynomial, the value of p of a is equal to the remainder of the division of p of x by x minus a. So there are two choices to find that number, that remainder. You either do the division or you just replace the x by a, and you will get the same answer. That's kind of the main result of this theorem. And this example 3. So please pause the video there and see if you can find what is the value when you plug in x negative 2 for x, what you get. Remember, you can just divide by x plus 2. So you can do that. Use synthetic division and it'll give you the remainder. Okay, and then of course try to do replacing the value of x and see that you get the same answer. Hoping that you pause the video, and here is the answer. So the remainder should be 5. So that is to say that when you replace negative 2 to the third power in parentheses, don't forget in parentheses, negative 2 to the third power plus 8 times negative 2 in parentheses to the second power plus 12 times negative 2 plus 5, you should get that number 5 also. All right, so you can check that with any calculator. So I'm gonna try that and see if I can squeeze in here. Well, maybe I'm gonna stop there for example 3 because then I don't want to make the video too long.